Yeah. And I was like, I said it was an empty.
I actually have it.
Some students.
One of my kids are like, my dog is demolished, literally ate. And they had to take to the doctor and they like.
I did high school. I never had any learning.
All right, as for today, we are going to continue looking at polynomials and some additional things that we can do with them. Specifically, we're going to start with adding and subtracting. So this is really just about combining like terms, and one of the techniques is referred to as the cross-out technique. So as you identify, as you write your next step, cross out the pieces that you have used in the previous step. Additionally, the big thing is descending order. So again, writing the highest degree first and then decreasing from there. So we can simultaneously combine like terms and, all right, write this in descending order. So looking at this first problem here, what's the highest degree?
X cubed.
3. All right, so the x cubed term. So let's start with that one. All right, so I see only a single x cubed term, and then this is the cross out technique is, oh, I used that one, so that one's done. Then, all right, so then I go to the next degree, which is x squared. So I see a positive x squared here and a negative 3x squared. So combining like terms, this is purely just adding the values. So x squared, what hidden number is in front of it?
1.
A 1. So I have 1x squared minus 3x squared, which leaves negative 2. All right, x squareds. So again, it's just adding the numbers and then attaching the variable that is associated. Oh, now those ones are done. So then I have the x's, negative 3x plus 7x.
And gonna be 4x.
4x, excellent. And now those ones are done. And again, you just keep crossing them out. If at the end you end up with like another x cubed or something, that means you missed it and you need to fix that one. And then lastly, 2 minus 5.
It's negative 3.
We have then accounted for every piece, all right? And this is in descending order. So again, what that means, we have the highest degree. So I have x cubes, x squareds, x's, and then x to the 0 power or the number term. So, yes, Brian.
So can we flip flop them and do like, just flip flop that? What would that be? And,
Flip flop, like ascending order?
yeah, like ascending order.
So, I mean, it actually was in ascending order. Negative 3 plus 4x minus 2x squared plus x cubed.
Yeah.
Like that?
Yeah.
Yes, this is ascending order. We don't write it like that because typically you want to deal with the x cubed first. Why would you want to deal with the higher exponent first? Yeah, because it's more complicated math, especially when like evaluating, right? If I put in 5x cubed, I want to deal with that one first. That's why all the instructions are always going to say descending order. So yes, technically correct minus the descending order. I mean, that is the correct combination of terms, all right? But get in the habit of writing things in descending order. All right. Again, another one. so. The big thing here, yes, absolutely, Fred. All right, we see, we're gonna start with the fives, but there's one other big thing going on here. We're subtracting, which means what happens to this negative? It rainbows through the entire second polynomial. So we have to be very, very careful with our signs, which means before I start combining like terms, let's rainbow that through, because that's usually the biggest mistake. So we want to make sure, all right, that we do that rainbow. And notice, I dropped all my parentheses. All right, I don't need to keep my parentheses there because once I have rainbowed that negative all the way through, all right, then it's just a matter of, again, combining like terms. And yes, all right, let's start with the 5. So 3x to the 5th and negative 2x to the 5th.
Use X to fix.
X to the 5th. Negative 4x to the 4th and positive 4x to the 4th.
It leaves nothing.
It leaves nothing. Oh, look, those cancel away. All right, what's next?
2x squared.
No, negative 3x.
So notice there's not one in the first term, but there is one in the second term. And then,
Positive 2x squared and minus 4x squared. Which leaves negative 2x squared.
and then the x's. Oh, you're right. So what about the x's? X to the first powers?
You don't have any.
Oh, there are none. So don't need to worry about that. And then you're absolutely correct. 3 and 5. Plus 8. And again, piece by piece, all right? Nothing to it. So let's take it up a notch. Because fractions are numbers too, all right?
No, not.
I refuse to believe it.
All right, so there's a couple approaches we can do here, all right? What is one approach? What could we do immediately if we wanted to?
Skip the problem.
Okay, that is always an option. I can create the common denominator for the entire fraction. And actually, for practice, let's do it that way. However, just as to be aware, you don't need to create the common denominator for the entire problem. Look term by term, x to the 4th and x to the 4th. So really, I just need to create the common denominator here, which you're exactly correct, is just 4, right? X cubes.
Oh, of course.
All right, so looking at the x cubes, which is just these. Oh, look, I don't actually even have to do anything for those. They already are a common denominator. X squareds, well, it's clearly 3, okay? So I can create common denominator within each step, but for practice, let's create the entire common denominator. So 2, 4, 8, and 3. Does common denominator jump out? 24. 12 doesn't work for which number? 8, right? But 12, I can create a common denominator with everything, so let's just do that. Because we love fractions, love.
I don't know who you're trying to convince.
You guys, obviously. I was like, I don't need convincing myself. I do love fractions. We're doing 24. Six, 18. All right, and simultaneously, okay, so creating the common denominator. Now, again, I'm kind of shortcutting the step, right? Because this one is, I'm multiplying this one by 6/6. This one is by 12/12. This one is by 3/3. This one will be by 12/12. That one's 24/24. This one is by 6/6, etc. All the rest of the numbers should be repeats. Oh, this one will be 8/8. Right? So I could create these common denominators piece at a time. All right, but also with these pieces, this needs to rainbow in. Technically, the addition rainbows in, but that one's gonna be super easy because it doesn't change anything. What do we have, 36? All right. So creating common denominator for the entire fraction. Is everyone with me with the fractions there?
Yeah.
Piece by piece. All right, rainbow the negative, rainbow the positive, quote rainbow. And then we're ready to start combining like terms. Where should we start? With the x to the fourth. So I have x to the fourth. All right, so let's see, there and there. 36 minus 18.
Isn't it 18?
18.
Wouldn't that be negative?
No, because 36/24 is the positive, negative 18/24, so it results in a
Oh,
positive.
I was looking at the wrong one. That's my bad. I was looking at the third exponent.
And again, it is super, like, keeping track of them, that is the only challenge of all this. I was like, it actually, nothing is too tough. Don't use your calculator, 36/24 minus 18/24, that is the goal. And we've talked about it before, right? So when you put that into your calculator. So 36/24, actually, let's do it this way. Negative 18 divided by 24 plus 36 divided by 24, all right? Everyone can input that in their calculator properly, right? Remember using the negative that's down here, not the subtraction over here, okay? And then that gets 0.75, all right? But let's keep this as fractions. We started as fractions. How do I turn that into a fraction?
I have no idea.
Your calculator, does anyone know?
What did you say?
Fraction button?
Yeah, where's the fraction button?
I have no idea.
Good guess.
Okay, you guys both have Casios, so I know you two are the wrong ones to answer.
Parentheses and then division, it's fraction, they're just division problems. So
Well,
you do.
no, but my calculator says 0.75.
Just
Math
and then it's a rack.
and frac.
More fancy.
Yes, not the Casio people. So then, yes, you hit math frac. All right, okay, we'll come back to that in a minute.
Almost sounds like trying to come up with creative cuss words.
All right, x cubed, all right, let's see, 12/24, negative 36/24. Oh, that's it. And so that becomes 24/24
That's one.
x cubed. Yes, so we're writing it out the full way. We're gonna reduce these in a minute.
I'm like not taking the last step.
And then the x squared terms. So I have 24/24 and plus 16/24, that leaves negative 8.
Why is that negative?
Excellent question. Why is that negative?
Because you're adding a positive to a negative.
And which one's the bigger?
Negative
The
is
negative. Negative 24/24, positive 16/24, right? This is negative 1 plus, what was this, like 2/3? Again, remember with fractions, you're just adding the numerator straight across. And again, your calculator, this is why I want to make sure everyone's solid with the calculator, because that's what it's there for. I was like, to do simple math. I was like, no, I was like, if you're a human calculator, great, all right? Otherwise, that's what the calculator is there for. That number plus that number, and then even put it in exactly math frac. I mean, you can skip the fractions entirely. I was just doing it for practice because fractions, everyone always like freaks out. All right, and then lastly, 21/24 minus 42/24 minus 12. Okay, that one I need to calculate with.
Wait,
You missed one.
Oh,
You just put 40.
negative
42x.
Yeah.
42/24. So I don't have to do anything with that. You're absolutely correct.
throw me off for a second.
Okay, so 21 minus 12. What is it, 9?
9.
9, all right, thank you. And then last step, let's reduce all these. So that's 3/4 x to the 4th minus x cubed minus 1/3 x squared minus, okay, that was, what was that initially? 7/4. Plus 3. Three eighths. And so again, we got these fractions way big just for practice to then just reduce them back down. But like I said from the beginning, some of those we didn't even need to create a common denominator if we were just combining like terms. At 7/4, we turned it into a fraction and then reduced it back down to its exact same number.
Love that.
All right, just for fun. All right, so adding and subtracting values, all right, and then putting it in descending order. The other thing is multiplying polynomials, so multiplying them together. And a lot of this goes back to the rules of exponents, because this is almost exactly what we were doing with those rules of exponents last class. Multiply each piece, multiply the numbers, then multiply the x's, then the y's, then the z's, etc. All right, so one variable at a time. So for this first one, -7 times 4.
-28.
-28. Then I have x to the 5th times x cubed. What do we do with those powers of exponents?
Time for
Add them. That becomes basically x to the 5 plus 3.
which is X, but 8.
So that's the big thing. This is all just about remembering the rules of exponents. So 3 times 4, 12. And then x times y, what does that become? xy. There's nothing to be done there. All right, getting a little more complicated. -4 times 6 times -3. Again, just the numbers.
When you work left to right. With like pivot.
Well, this is all multiply, so I'm just taking the numbers. -4 times 6 times -3. Right, so just multiply the numbers together. Go ahead. 72, negative?
Positive.
Are we sure?
Yeah, because there's
Well,
two negatives.
There's 2 negatives, makes a positive. And then y to the 5th times y squared times y cubed.
Why the 10th?
Y to the 10th, just adding the exponents again. So this is multiplying monomials, all right, that is single terms. This is all just following the powers of exponents. Right? And actually, I think multiplying the variables is easier than multiplying the numbers because you just add the exponents versus, I'm like 4 times 6, okay, 24 times 3 more, okay, just 48, 72, right? I was like, I could do the y's way faster than those numbers. All right, so piece by piece. Similarly, multiplying a monomial that is a single term into a polynomial several terms. This is rainbowing, but this is rainbowing with, all right, those rules of exponents that we just did. So one term at a time. 2x squared times x cubed. So remember, what's the number in front of that x cubed?
1.
1. So 2 times 1?
2.
2. X squared times x cubed.
X to the 5th.
X to the 5th. All right. 2 times negative 7.
Negative 14.
X squared times x squared. And then etc. right? Piece by piece. All right. This is simply just still, this is all still rainbowing. All right. We are over a quarter of the way through this course, and most of what we do is rainbow. All right. That's why it's part of what? With the rainbow, what is associated with the rainbow?
Pot of gold.
In this class. The dance move. Okay, so remember, right? Rainbow with the hip hop.
I forgot.
Right? Remember that? You guys forgot? Well, that's good news because we're about to learn a new move. That's why I was refreshing us. When multiplying polynomials, that is 2 terms by 2 terms. All right, you may have heard the term FOIL, first, outside, inside, last. All right, that is multiplying a single piece, all right, one at a time. So using FOIL, let's multiply this binomial times binomial, these 2 terms times 2 terms. So it says first. That means the first in each of them. So x times x, what does that become? X squared. Outside.
Would that be 4x? Negative 4x?
Yes, so the outside terms, negative 4x. The inside terms,
5x.
and the last terms.
Negative.
So FOIL is really nice. The problem with FOIL is this, it only works with 2 by 2. Notice it counted everything twice, all right? So each term was counted twice, and we got all the terms, and then our last step, as always, what do we do in between every step in algebra?
Simplify.
Simplify. So x squared plus x minus 20. The downside of FOIL is this. It only works with 2 by 2. But unfortunately, way too often, we have more than 2 terms. That one has 4. All right, a lot of times 4 by 4s, 5 by 5s, 6 by 6s. All right. FOIL doesn't work because you run out of the letters. First, outside, inside, last only counts for 4 pieces. All right, so it only works 2 by 2. The box method is the method that I prefer and I will do from here on out. So there's FOIL once. For those who have learned FOIL and love it, you may use it, of course. It is one technique. It is a lesser technique. The box technique says line up terms across the top and line up the other terms across the side. Then you multiply into each box. And it's still doing the same thing. X times x is x squared. 5 times x is 5x. Negative 4 times x is negative 4x. And negative 4 times 5 is negative 20. Then, all right, so you multiply into the box. And sum terms out of the box. What's nice also about the box is if you write things in descending order along the box, your terms line up on the diagonal. So when you're pulling these terms out, I see my x squared, and then I see 5x minus 4x, that's plus x. And then across that last line, negative 20. Now, do you get the same answer? Of course you do. It is just another technique. I like the box method, all right? One, that it extends beyond 2 by 2 terms, all right? And the other reason, the big reason, is it's a new move in our polynomial dance. All right, so everyone rise.
Everybody dance now.
All right, so let's refresh, all right, on our first dance move, all right? The rainbow. So do the rainbow, do the rainbow, do the rainbow. Don't forget the hip hop. See you guys. All right, don't forget the hip hop. All right, then the next move is the box. Do the box, do the box. Hip hop again. Notice hip hop, hip hop. Do the box, do the box, do the box. All right?
Oh, I know.
So I emphasize these moves, all right, for two reasons. One, it is super fun and everyone looks super cool. All right. The other reason, it's because they're important and we use them all the time. And I want you to make associations so you remember them. To that end, all right, we have lots of special products. Differences of squares, perfect square trinomials, all right? Those terms are basically irrelevant because if you can multiply the terms out, you don't actually need to know what they're called. X plus 4, X minus 4. Now, you can use the shortcut formula there, but every single time, guess what we can do? How do I multiply two terms? With the box. So I don't need to know that fancy rule that's there. All I need to know is how to do the box. Line up one set of terms along the columns, one on the rows, multiply into the box. And sum the terms out. Here's the other nice thing. When I'm summing the terms out, I see I have x squared. And notice 4x minus 4x.
You don't have that anymore, so it's just minus 16.
Yes, exactly correct. And so the box is really nice because again, along the diagonals, your terms are lining up. Perfect square trinomial is another one with a fancy formula. And also I'm stating the official terms because when you get the question in Pearson MyLab Mastering, it's always like, oh, this is obviously a perfect square trinomial, so just use this formula. Okay? Use the methodology. An important thing here, multiply 2x plus 3 squared. Remember, what does squared mean, right? What does 5 squared actually mean?
5 times 5.
5 times 5. It is super important. Exponents do not rainbow. That actually means 2x plus 3 times 2x plus 3. So remember what it actually means, which means that is a box. So multiply into each piece of the box, sum the terms out, combining like terms.
Should be 4x squared plus 12x plus
4x squared plus,
9. 12x plus 9.
okay, just making sure that's what you said.
Yep.
4x squared plus 12x plus 9. The biggest issue is that this first step is the biggest problem I see here. We talk about rainbow so much that people are like, oh, just rainbow the squared through. Right, that becomes 4x squared plus 9, but you would have forgotten the middle term, all right? So remember what exponents mean. It means something times itself. Similarly, multiply. So remember again what this means. 5a plus 1 times 5a plus 1 times 5a minus 1 times 5a minus 1. Do not be fooled by those squareds. In order to do this many terms, guess what we do?
Make a bigger box.
Make a bit, well, this is actually multiple boxes. Start with just the first two. All right. So let's start. While I'm at it, all right, now I could take those first two, because those first two, 5a plus 1 times 5a plus 1 becomes 25a squared plus 10a plus 1. Then I could make a box with the second one, but in order to save ourselves a little bit of time, we're gonna need 3 boxes regardless. Let's multiply the last two terms, 5a minus 1 and 5a minus 1. And now notice what we have. So what we had above now becomes so from the first box, 25a squared plus 10a plus 1. From the second box, 25a squared minus 10a plus 1. Now what do we get to do?
Put 'em in a box.
Put them in another box, and now a 3x3 box. And this is what I was emphasizing. Once you go beyond 2x2, FOIL no longer works. Okay? First, outside, inside, last misses half a dozen terms on this. All right? So highly encourage. Now we do a 3x3 box. So, and then this is why I like the box too. When I see people, now be aware, there is another technique that you may have seen in what is called extended rainbow. I take my first term and I rainbow it into all 3 of these terms. Then I take my second term and I rainbow it into all 3 of these terms. Then I take my last term and rainbow it into all 3 terms. It's essentially what the box is doing, but organized. When I see people doing that extended rainbow, I see them lose a term. The box says, I will have 9 terms, all right? And so it keeps your information organized while doing it. Also, notice our numbers are getting pretty big, so the box helps us organize that as well. And, all right, as I'm about to get ready to pull my numbers out, does anyone see anything fun that happens? Oh, we cross some of them out. Negative 250a cubed, positive 250a cubed, 10a, negative 10a. What about those 25a squareds? Cross both those out? No, why not?
They're both positive.
Yes, okay. Be careful, don't get too excited with the canceling and cross out things that are not opposite signs.
Negative 50.
Someone have a question? Okay. And then again, along the diagonal, another reason I love the box, along this diagonal right here. All right, and technically along all the diagonals. That's how we were able to identify. But I could see, all right, 25a squared, negative 100a squared, 25a squared, right? So I'm just doing 25 minus 100 plus 25, negative 50. So again, your numbers, everything lines up really, really cleanly with the box. No matter how complicated, we did 3 boxes here, no matter how complicated that multiplication gets, it organizes it all so well. Is everyone okay? Good stuff. Great. All right, just to show you the other method, one time only. All right, let's do the extended rainbow. Ugh.
Exactly.
Just so you've seen it.
I don't like that you give me a thing that works and then show me it just because you have to, because then my brain sits there and it's like, well, what do I do? And I panic.
It's not that I have to, it's that Okay. I want to in the sense that I don't know what your previous math experience is and everyone had a different teacher. And so I want, in case you've already seen this, I don't want to have you to relearn something. Just want to show you what I think the best method is, but not everyone agrees with me. So the extended rainbow means that basically I break that up and then I rainbow each piece. And some people really like this one. So as I rainbow, because I'm just doing one term at a time. And then I can combine like terms basically just like we were doing before. And I would cross them out, but I want you to be able to see them. And whether you box, do extended foil or extended rainbow, of course, all these methods work. Also, I want to show you the multiple methods because that way, hey, do all three and you always are correct, right? If you do 3 methods and get 3 different answers, then something went wrong, right? What?
I already like the box method.
You already or don't like?
I already like the box method.
You already liked, so you'd already seen it before. Yes, I agree. And here is why. All right, so one last problem. And again, why I love the box. All right, 3 by 3. Just so much is going on there. I'm just so confused. I don't know where to start. Oh, let's start with a picture, right? We love pictures because pictures are worth 1,000 words.
Pictures are worth whatever.
There's that.
So multiply into the box each term. And whenever possible, take a glance at the box and see if we can cancel anything. Can we cancel anything?
No.
Negative 4xy and positive 4xy.
4xy and negative 4xy. Anything else?
Negative 6y and positive 6y.
Yep. And again, what about the 6x and 6x?
They're both positive.
They're both positive. Do not cancel there. Now, this one is tricky in regards to descending order. When doing descending order, the recommended approach is descending in X. All right. If you have multiple variables, always do descending in X and ascending in other variables. So descending in X means 4x squared plus 12x plus 9 minus 4y squared. I am ascending in Y because no Y, no Y, no Y. All right. Decreasing one variable as I increase the other. All right. All kinds of good stuff. All right, there is a wonderful activity, chapter 5, activity 2 for everyone to take a look at.